Welcome, I'm your host, Joseph Vick, the Museum Education Director at the U.S. Space and Rocket Center in Huntsville, Alabama. This video is brought to you in collaboration with the Rocket Center and NASA Marshall Space Flight Center's Office of Planetary Missions. Today we're going to be talking about the NASA space probe DART. The Double Asteroid Redirection Test Mission, or DART, is a planetary defense-driven test of technologies for preventing an impact of Earth by a hazardous asteroid. DART will be the first demonstration of the Kinetic Impactor technique to change the motion of an asteroid in space. With a planned launch in November of 2021 on a Falcon 9 rocket and a tentative impact date of October 2022, we will soon know if we can redirect asteroids on a collision course with Earth. So join me along with Clayton Kachele, the DART mission manager, to learn more about this exciting space mission.
It's amazing the work we get to do because we know it's about this bigger mission of protecting the Earth, saving people's lives. In this, we're doing technology demonstrators to show how advanced we can make new systems. We've included some new instruments that will allow deeper space exploration. The first is roll-out solar arrays. They roll out kind of like you roll out wrapping paper. They're going to provide a ton of power, but in a compact design and lighter weight than normal. DART will also have what's called Next-C. We have xenon tanks on the spacecraft that will then receive electric charge and pass through a gridded ion thruster to provide power. We also have the LiCi-Cube, which is a small CubeSat designed by the Italian Space Agency, which will be ejected from DART about 5 to 7 days prior to impact. And they will be there to take images of the actual impact. We're observing the Didymos system, which has the main asteroid, Didymos, and then it has a moon, Dimorphos.
Didymos is a near-Earth binary asteroid. That means it's a space rock that comes within 93 million miles of Earth and comes in two parts: one larger asteroid body and its smaller orbiting moonlet. The DART spacecraft will achieve the kinetic impact deflection by deliberately crashing itself into the moonlet. The collision will change the speed of the moonlet in its orbit around the main body. This will change the orbital period of the moonlet by several minutes, enough to be observed and measured using telescopes on Earth. But how can we demonstrate the DART mission here on the surface of the Earth? With curling. So I have in front of me curlers that we're going to be using for our kinetic energy demonstration. Kinetic energy is the energy of motion. And with the DART mission, it's going to actually impact part of the asteroid binary system, the moonlet, and knock it out of the way. Curling is a great example for this because curling is an Olympic sport where it uses curlers like this one to slide across ice. These curlers are wheel-based, but we're going to be using this demonstration as movement of impact, so that it's impact and moved away from that binary system. Now that was a kinetic impact. Notice the kinetic energy hitting from one curl to the other, transferring that energy and moving the moonlet out away from the binary. Now this is curling in a curling mat, but I have a way that you can do this at home. Now you can make your very own DART impactor at home using the following materials: 2 ping pong balls, a bendy straw, a larger straw in diameter than your bendy straw, and tape. Easiest way is take your larger straw diameter and at one of the ends, take, press, and fold down. That creates an airtight seal inside. And from that, add a strip of tape at that bend so it stays in place. What you just created was the impactor part of your DART mission. Place this over your bendy straw, and you have your DART impactor. And we're going to impact the moonlet of our Didymos binary asteroid system. Redirecting the path of asteroids was once thought to be science fiction, but DART is aiming to show that it is science fact. If DART proves to be successful, the impact will potentially save lives of future humans right here on Earth. Thanks for watching.